This is section 7.1, rational expressions and functions, multiplying and dividing. This section covers a lot of little topics. It's going to feel like it's jumping around a little bit, but where we are heading eventually is solving equations with these things, and we need all of these little skills in order to be able to do that. Okay, a rational expression or rational number is anything that can be written as a fraction, okay? And the fundamental property of rational numbers is this. If you have a over b, you're allowed to multiply the top and bottom by the same value as long as it's not a zero. And it works the other way as well. If you have a multiplication on the top and a multiplication on the bottom, and you can divide both by the same thing, and here I can divide by a c, I can go back to here. Now notice that this is multiplication in here. If it's addition or subtraction, it's not going to work, okay? We're going to use these ideas to both reduce fractions and to rewrite fractions with new denominators. Okay. Now, one of the things that's different about a rational expression versus just regular fractions is that we are going to be allowed to have variables in our denominators. We have dealt with fractions in equations before, but we have never had them where an x or our variable in general is in the denominator. Okay, and that changes some things. Domain, you may remember from chapter 3 when we talked about functions. These are all legal x values. In this section, what we need to worry about is a value that makes the denominator 0. Remember that a fraction is a division and we are never allowed to divide by 0. Okay? The instructions for this type of problem will be written in one of two ways. It might say to find the values that must be excluded from the domain, and that's asking us to go find the numbers that may give us a 0 in the bottom, if there are any. And they might ask you to give the domain. The math is the same, the only difference is how you write your answer, okay? Now here, on this problem, find the values that must be excluded from the domain, and then give the domain. Although the numerator is important in general, it has no role at all whatsoever when it comes to finding the domain. So what we want to know is we want to figure out where our denominator is 0 so we can exclude that from the domain. All you have to do is you take your denominator, whatever it is, and set it equal to 0 and solve. Okay, so subtract 1 from both sides. 7x is equal to -1. Divide both sides by a 7, and that should be a negative right there. You get x is equal to -1/7. If you are asked what number or numbers must be excluded from the domain, your answer is -1/7. If you are asked to give the domain, what they want you to do is they want you to write something in set builder notation. And this is the set of all x such that we use something similar to this when we had all real numbers as our answer to a system of equations. In that case, it was xy because we were talking about the set of all ordered pairs. Now we're just talking about all values of x. Basically, this is saying x can be anything as long as x does not equal -1/7. The math is the same. You found that value. The difference is how it's written. This is the number that has to be excluded. This is what the domain looks like after you have excluded that number. Okay, so let's try another one here. We're still supposed to find the domain, or what must be excluded. And so we have to look at the denominator, whatever it is. We need to figure out where this thing is 0. So you take 3x squared plus 11x minus 42, and you set that equal to 0. Okay. Now what we have is we have a quadratic because we have a square. So we're going to have to use the zero factor property. We need a 0 on one side, and then we have to factor this. Okay. So I do not have a GCF. These are not perfect squares. There's a number in front, so I need to figure out what 3 times -42 is, and that's going to be -126. So we're looking for two numbers that multiply to what did I say, 126, and adds to 11. So I start using my calculator and find everything that multiplies to 126, you get 1 and 126, 2 and 63, 3 and 42, 6 and 21, 7 and 18, 9 and 14, and that's all. Okay, we're multiplying to a negative, so one of these sides is going to be negative. We're adding to a positive number, so that means the negative will be on the smaller side. Where can we get an 11? Right here with negative 7 and 18. So we rewrite this as 3x squared minus 7x plus 18x minus 42 is equal to 0. Okay, now we have our plus sign in the middle, so, and I'll rewrite that as a square there so it's a little bit more clear. Okay, from the first group, I can factor out an x. That leaves me with 3x minus 7 plus. From the second group, I can factor out a 6, leaving me with 3x minus 7 equals 0. So this factors as 3x minus 7 times x plus 6, and that equals 0. Now we set each of these equal to 0. And solve these. So as I add 7 to both sides, I get 3x equals 7, divide by 3. So x is equal to 7/3. And here, you subtract 6 from both sides, and you get that x is equal to negative 6. Okay, so if you were asked what number or numbers must be excluded from the domain, you would write negative 6 and 7/3. And in my math lab, they will ask you to put a comma between them. Okay, so if you're at what numbers must be excluded, those two. Now, if you were asked to actually give the domain, this is the set of all x such that x does not equal, and again, we list these two things with a comma between, negative 6 or 7/3. Basically, x can be any number. It's legal to be any number as long as it's not one of these two, because these two are the only numbers that will give us a 0 in the denominator, and we cannot have that.